This is Jo from Maths Tutor Me. Today we're going to review the 4 index laws. So just to recap, the first index law, if we have terms that are multiplied together that have the same bases, we can add the powers together. If we have terms with the same bases that are divided, we subtract the powers. If we have something to the power of 0, it is always equal to 1. And if we have something to a power, in brackets to another power, then you times the powers together. So let's do a few questions using each of those rules. So here's our first question. 16m to the power of 7 divided by 2m to the power of 4. Okay, so we are dividing. So the first thing we want to do is to divide the numbers at the front. 16 divided by 2 is 8. Okay, then when we are looking at the pronumerals, the base is m, and when you're dividing you want to subtract the powers. So 7 minus 4 is 3. In question 2, we have 15y squared times 3y to the power of 6. Okay, we're multiplying, so we want to multiply the numbers at the front. 15 times 3 is 45. Y is the base, and when we're multiplying and we have the same bases, we want to add the powers. 2 plus 6 is 8. In question 3, I have a 4 at the front of 3m to the power of 7 to the power of 0. Now, as soon as we have a power of 0, that's this third law here, anything to the power of 0 is equal to 1. So this whole thing here, that whole thing to the power of 0 is just equal to 1. So I really just have 4 times by 1, because of this 4 at the front, which is just equal to 4. Okay? Question 4, we have some brackets here. We have 2x to the power of 5 and y to the power of 3. And all of that is to the power of 4. Okay, to do that, we have to put 2 to the power of 4. So that's 2 times 2 times 2 times 2. So you may know that, or if you don't, remember you can use your calculator. 2 to the power of 4 equals 16. Okay, then for the pronumerals, that using this law over here, we want to times the powers together. So x is the base. I want to times the 5 with the 4 to get 20, x to the power of 20. When y is the base, I times the 3 times 4 to get 12. Okay, question 5. We have brackets here, 3y to the power of 3, all squared, times 2y to the power of 4, all divided by 6y times y to the power of 5. Okay, first of all, let's expand out the top bracket here. 3y to the power of 3, all squared. We have to do 3 squared. 3 squared is 9. And we have to times these powers together. 3 times 2 is 6, so y to the power of 6. Okay, we're going to, in a moment, times that by 2y to the power of 4. And on the bottom, we can times those together now. We have 6 times a 1, so just 6. And y to the power of 1, that would be, times y to the power of 5. We would add the powers to be y to the power of 6. Okay, we could cancel here, or we could multiply and do our cancelling at the end. I might keep multiplying and I will do my cancelling in a moment. 9 times 2 is 18. Y to the power of 6 times y to the power of 4. We want to add those powers there, which makes 10 over 6y to the power of 6. Okay, now to cancel off. 18 can be divided by 6. It goes 3 times. And I could cancel the 6 y's that are there with 6 of those, giving me 4 left. So all that I have left, my denominator is completely gone. So I just have, I'll write it on the side here, 3 y to the power of 4 remaining. Okay, question 6. 7 to the power of 2x divide by 7 to the power of x plus 1. This is a little bit unusual. You may not be used to this kind of question. We have pronumerals as our power. Okay, so the same rules still apply. If I have the same base and 7 is my base, then I just need to subtract the powers. So I have got a 2x, and then I want to subtract x plus 1. Okay, I've put that in brackets to make sure that the minus gets expanded the whole way through there. So let's expand that bracket out. 2x minus x minus 1. So 2x minus x makes 1x, or just x, and minus 1. So my simplified answer is 7 to the power of x minus 1. On the bottom, last question here, number 7. Let's expand these brackets first. So to expand them, I need to times the powers. So the 3 is the base. M times 2, or 2 times m, is 2m. I'm going to divide that by 3 is the base. I need to times these powers. So I need to do 2 times 1, which is 2, and 2 times minus m, which is minus 2m. Okay, now that I've expanded the brackets, I can do the division. So if I'm dividing, the 3 is the base, I want to subtract the powers. So 2m, and then I want to subtract, use the brackets again, 2 minus 2m. Okay, expand that bracket through, 3 to the power of 2m minus 2, and then that minus comes through here to make it a plus 2m. So I have 2m plus 2m, making 3 to the power of 4m minus 2. And there it is. Okay, so here is 7 questions, just like the ones that I have just shown you, for you to have a practice and see if you can remember what we've just learned. So pause the video and try these questions, and then restart the video to go through the answers with me. So question 1. We have 15h to the power of 4 divided by 5h to the power of 3. So we first of all need to divide these numbers at the front. 15 divided by 5 goes 3 times. Then with the pronumerals, they have the same bases, so h is the base, and when we're dividing, we want to subtract the powers. 4 minus 3 is 1, but we don't normally write a 1 when we're doing algebra questions. So question 2. 7a to the power of 5 times 4a squared. Okay, so we're timesing, so we times the numbers at the front. 7 times 4 is 28. A is the base of both of those, and when you times, you want to add the powers. 5 times 2 is 7. 5 plus 2 is 7, sorry. Okay, question 3. 3f bracket 8f to the power of 5, all to the power of 0. So whenever we have something to the power of 0, that whole thing is just equal to 1, the part that is to the power of 0. These other parts, though, they're not part of the bracket that's to the power of 0, so they're still there. So I still have a 3f times by the 1, but timesing by 1 doesn't really change anything. I'll just be left with 3f. Question 4. I have a 3c to the power of 6 in brackets to the power of 2. So I need to do the 3 to the power of 2. 3 to the power of 2 is 3 times 3, which is 9. Okay, and with the pronumeral, c is the base, I need to multiply the powers. 6 times 2 is 12. Question 5. X squared times x times y in brackets to the power of 4, all over bracket 2x close bracket to the power of 3. So first of all, let's expand all those brackets. So we'll leave the x squared at the beginning there. To do this, all to the power of 4, I need to times the powers. Now these would both be 1s because there's no other number there. So 1 times 4 is 4. So it would be x to the power of 4. And for the y, also 1 times 4, which is 4. Okay, so that's what it will become. Over 2 to the power of 3 is 8. And x to the power of 3 is just x to the power of 3. Let's times the top together. So the x's have the same base, so we would times them together, which will add the powers. So 2 plus 4 is 6, and the y to the power of 4 is unchanged, it just sits afterwards, over 8x to the power of 3. Now because we have x on the top and the bottom, we're dividing those, or we can cancel those, it's the same thing. So I can cancel off those 3 with 3 of those to have 3 left. So my final answer will be x to the power of 3, y to the power of 4, all over 8 that is left on the bottom. Getting a bit squashy in there, sorry about that. Hope you can read what I've written down there. Question 6. K to the power of 2x plus 1 times k to the power of x. Okay, so we have x's in our powers here. K is my common base, so k is going to stay the base, and when we're multiplying we want to add the powers. So I want to do 2x plus 1 plus another x. Okay, so now I can just add the x terms together in here. 2x plus x is 3x, so it's k to the power of 3x, and I also have a plus 1. And that's finished. Finally, question 7. Let's expand these brackets first, which means I need to multiply the powers. So 3 is the base. I need to do x times 2, which is 2x, and 2 times 2, which is 4. Okay, then I'm dividing that by 3 to the power of x plus 1. Now if I'm dividing and I have the same bases, I want to subtract the powers. So 3 stays as the base, and I'll have 2x plus 4, and then I want to minus the x, and we could have our bracket here, or I can do it in one step and I can expand the minus through to have a minus 1 as well. Then I can collect up my like terms here. 3 is the base, 2x minus x is just 1x or x, and 4 minus 1 is a positive 3. So 3 to the power of x plus 3 is my final answer. Hopefully you're able to follow those solutions there, and hopefully you got some of those right, or all of those right, hopefully. Keep practicing, and I will see you next time. Bye.